Now let's leverage some of Python's basic programming features with data cleaning in pandas. In order for us to concatenate data frames, they must be loaded and placed into a Python list. We can load each dataset individually if there are only a few datasets to be concatenated. But what happens when there are tens, hundreds, or thousands of files we need to load and concatenate? Manually loading each one is not a viable option. We can use the glob function in the glob library to find files and use a Python for loop to read in all the data files. Globbing is a simple way for Python to do file name pattern matching. We can use various wildcards to specify a file name pattern we are looking for. A wildcard is a symbol that will match any arbitrary number of characters. The asterisk is a type of wildcard that matches any string. Contrast this with the question mark that will only allow us to match one character. For example, asterisk.csv will match any file ending in .csv. And filename underscore question mark .csv will match file underscore and then any single character, then the CSV file extension. This character can be a number 0 to 9 or any letter A to Z. The glob function will return a Python list of file names that match the pattern. We can use this list of file names to systematically load into pandas data frames. Globbing will give us a list of file names. Now we want to load each file into pandas and then add all the data frames into a list. We can pass this list of data frames to the concat function to concatenate multiple data sets all at once. Now let's put the find and concatenation example together. We import the glob module. We use the glob function to look for all CSV files by providing the pattern asterisk.csv. One way we can create a list of data frames is by using a for loop. We first initialize an empty list that we will append data frames to. Then we write a for loop that will go through each of the file names from globbing. We have a list of file names from the CSV files. We will iterate through each of the file names. Each file name iteration we will call file name. Then we can use pandas to load the file name into a data frame. Finally, we can then append the loaded data frame into a list. The end result will be a list of data frames from the glob results. We can then use this list to concatenate the list of data frames into a single data frame. Now it's your turn to find and concatenate data. Most of data cleaning will involve string manipulation because most of the world's data is unstructured text. You will also have to do string manipulations to make datasets consistent with one another, so you can work with or combine them later. Let's first consider strings that contain monetary values. There are many ways a monetary value can be represented: an integer on its own, an integer with a $sign, a floating point number with a $sign and 2 digits after the decimal point, a floating point number with a $sign and multiple digits after the decimal point. We want a way to check and validate these values and let us know if there's an error in our data, like the last point here that has 3 decimal values instead of 2. Python has a suite of built-in methods and libraries for string manipulation. The RE library for regular expressions is used for string pattern matching. Regular expressions give us a formal way to specify a pattern. It does this with a sequence of characters. We've seen some pattern matching before when we use the glob module. Here's a list of monetary values again. Let's write a regular expression to match each of the values. If we just wanted to match an arbitrary number of numeric values, we can use the regex pattern \d to represent any digit, followed by an asterisk to match it 0 or more times. For an integer that has a $sign in it, we have to do something different. The $sign actually has a special meaning in regex. It means to match from the end of a string. But in our example, we want the $sign to actually mean the $sign character. So we will have to do what's called escape the $. We accomplish this by using a backslash followed by the $. Then, to match the monetary value, we can use the \d asterisk just like before. To match a monetary value with decimal points, we can take the pattern we just wrote and extend it to match a period followed by more digits. The period, like the $, has a special meaning in regex. Instead of matching 0 or more times, like the asterisk, the period matches any one character. We have to escape the period as well with \period. Then, to match the decimal values, we can use \d asterisk. There's nothing wrong with the previous pattern, but we know that the decimal values in money are only 2 digits long. Instead of using \d asterisk to match the decimal values, we can use \d curly bracket 2 to match exactly 2 digits. Let's take the pattern one step further. We can take the previous pattern and put a caret in the beginning and a $sign at the end. The caret will tell the pattern to start the pattern match at the beginning of the value, and the $sign will tell the pattern to match at the end of the value. This way, it will match exactly what we specified in our regex. Otherwise, the regex would also match the string, I have 1789 USD. To use a regular expression, the most efficient way is to compile the pattern first, then use the pattern to match values. Compiling the pattern essentially saves the pattern into a variable that we can use to match over and over across multiple strings. This is useful when working in pandas because we typically want to match or validate values down a column of values. To use a regular expression to match monetary values, we compile and save the pattern with the compile function as seen here. We can use the match method to match the pattern to a string by passing the method the string we want to match. This will return a match object. We can convert the match object into a true-false Boolean value using the Python built-in bool. Here you can see our pattern matches the string we passed into the match method. Let's first practice writing regular expressions on their own before using them on columns of data.